Ladies and gentlemen, welcome to another episode of Cosmic Catastrophe on Revolution Radio. The twist is we're not on Revolution Radio.
Not today.
I am your host, Diamond, and joining us is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome to the program. Not on the radio today for another week. Hopefully they're going to get that problem fixed.
Yeah. Can you adjust your speaker? I'm echoing.
Okay.
Thank you.
Yeah, you're real loud here. That should do it.
Okay. Yeah, that sounds much better.
Okay, today's show is going to be a mind bender. We're going to be talking about natural climate variability and climate cycles, which, amazingly enough, have made it into the news cycle.
Yeah. What do you know?
And for a number of reasons, and we're going to get into that right from the rip here. We're going to go over Albedo. We're going to talk about some proxy data. And the fun fact that it was much warmer in the recent past, and more evidence is coming to light that that's true.
Yeah.
How do you like them apples?
Yeah. And it's interesting too that, like, I remember a couple of years ago, the mainstream media was trying to claim that the warmer periods of the recent past weren't any warmer than today, or they weren't really warm at all, or whatever. And it's like the data clearly shows that it was warmer.
Right. So what they did was they altered the data to show that it wasn't warmer in the past, when in fact it was. And there is a multitude of paths of evidence that are exposing the lies that they've been perpetrating for decades.
Mm-hmm.
So we're going to start by sharing the screen. Let me know when you can see the ship tracks.
I can see.
All righty. We'll get to that in a minute. So here's the big article and the big headline coming out from multiple sources. The Atlantic is cooling at a mysteriously fast rate after months of fear-mongering. That's actually what it should say.
Right.
The subheading is, the sudden shift in water temperatures is puzzling scientists. Now, there's not a single scientist that this would puzzle if they looked into the data for 5 seconds.
Mm-hmm.
So this is kind of amazing that they can get away with this. And most of the sheep on Earth will read the headlines, the subheading, and then look at this pretty picture and be like, wow, the climate is broken. It's all our fault.
Yeah. Well, and they've been primed to think that some kind of anomaly like this is part of climate change in and of itself, right? Because it was once global warming, and then they had to change it to climate change, because they started talking about, like, well, sometimes there's more storms, sometimes there's less, they just start talking about how everything is becoming completely extreme, one direction or the other, so now people are primed to think that cooling in the Atlantic is just going to be part of anthropogenic climate change.
Yeah, well, if you watch the Mark Morano interview I did, he reveals the obvious thing that many climate scientists have been screaming at the top of their lungs, including Ryan Maui, who is not really a climate denier like us. He's more in the mainstream, but he looks at data, so he has to give you the data. And his data shows that there is no climate emergency. There is no increase in tropical storms or tornadoes or hurricanes, none. In fact, the actual data shows a 99% reduction in climate deaths over the last 100 years.
Right.
This is the safest time to be alive. We have the least amount of hurricanes and tornadoes, and this is the best time. And yet, the majority of the population thinks we're all burning up, we're in a climate emergency, there's global boiling, and so on and so forth.
Right. I really appreciated Morano's point, too, about how wildfires is like the worst representation of climate you could imagine, right? Because there's so many factors that go into wildfires. And then despite all of that, if you actually look at the data, wildfires are dramatically less than they have been in the past.
And the 5 biggest wildfires in the last 3 years all started by humans.
Right.
The largest wildfire in New Mexico history was started by the government.
Right.
None of these have anything to do with climate. It has everything to do with stupidity and arson.
Right. And it also doesn't have anything to do with, like, I don't know, like space lasers and stuff, right? There's a lot of conspiracies about
Right.
how wildfires start, but you don't even need that. There's so many potential causes. There's, like you said, in arson, there's lightning, there, how the forest is managed. There's all of these different factors. So you don't need anything else to explain it.
Yet we're not taxing human stupidity.
Right. Maybe we should.
That would actually be practical.
Yeah, right.
Now, this sudden shift in water temperatures is not puzzling any actual scientist.
Mm-hmm.
Scientists know there's climate cycles, and people that actually study the actual climate, not climate scientists. Let's get this clear. In the last 20 years, a new branch of climatology came out called climate science. Its entire premise, all of its textbooks are based on an initial premise, which is a lie, that somehow CO2 is the climate control knob, and there's not a single peer-reviewed paper that has shown this to be true. Yeah. What we have seen is that humans contribute 4% of the total annual CO2 budget on Earth. Therefore, humans cannot be responsible. Even if CO2 does something to the climate, we are such a negligible part of the over CO2 package that it's almost ludicrous that our entire world, policies and governments are run on this fraud.
Right. And more than it just being, let's say us contributing 4%, right? That's 4% of a trace gas that is 0.04% of the entire atmosphere.
It gets, yeah, it's mind-boggling.
It's so incredibly negligible. It's not even funny.
So what's going on? Well, I'll show you right here. What's going on is that regular patterns occur and the sea surface temperature shifts dramatically on annual and multi-annual scales, meaning 1 to 3 years. And we refer to this as the Niños and Niñas, El Niño and La Niña. And here we're looking at the entire high-resolution data set, because we've only have satellites looking at this stuff for about 4 decades. So this goes back to 1982. It shows you what they have arbitrarily termed the El Nino threshold. That's this dotted line in red, and the La Nina threshold, the dotted line in blue. What it represents is areas of tropical oceans that rapidly shift in temperature. And take a look at what's just happened in the last month here on the far side of the graph. This is the largest drop from El Nino to La Nina in a period of months in recorded history. But scientists are baffled.
Yeah.
Is that insane?
Right.
And I also want to point out that the 3 hottest times on Earth, which they're claiming is now, 2016 and or 2020, and the largest. So these El Ninos are what they use back here. Was a warming spike to scare the public.
Yeah.
The first time it happened when it was proven that global warming was a thing is right here during this spike. After years of cold temperatures in the ocean, it got really hot one summer and it had to be our fault.
Right.
And now it's really hot now in some places, so it must be our fault again.
I mean, it's like when you look at this graph, it just illustrates how ridiculous it is in the sense that, like, you're kind of basing this off of a 5-year period, like roughly like 2010 to 2015, right? That because it was cooler, that therefore, oh my God, as soon as 2016, 2017 comes around, oh my God, look at what's happening. It's like, oh, that's all based on the last whopping 5 years.
Right. And so all the runaway global warming is simply 1, 2, 3, 4, 5, 6 Nino spikes, 3 of which actually reached the threshold into full El Nino, the biggest one we just had, in all the way back into the 80s. I can remember in the late 80s some huge heat waves across the East Coast.
I don't really remember that. I do remember some harsher winters, though, in the 80s.
Well, that would probably be down here, the La Nina.
Yeah. Yeah.
And so we're about to enter a La Nina, and it's pretty much confirmed. And it's confirmed by this pattern here so we've got South America here. When you get this cold water, which always comes up here. See, we have cold water coming down all the way in the West Coast. That's why it's so freezing when you go into the ocean of California.
Yeah.
Much different on the East Coast. But what we do have, and our friend Andrew Clark, who just came into town, confirmed it, that the ocean temperature off of New Jersey is right now freezing.
Yeah.
Because it is.
Yeah.
Showing like 50, 60-degree water all the way down to Virginia. That's not the, go ahead.
Well, I mean, I'm just like, imagining being back living in the East Coast, like going to the Jersey Shore or whatever, and you've been going every year, every summer, and then all of a sudden the water like seems way colder than what you remember from past years. That must be very disconcerting if you don't know anything about the BS of the climate hoax.
Yeah, indeed. And so this cold plume up here, this is the signature, the one that wraps around South America and out into the tropical Pacific here.
Yeah.
This is what triggers La Nina. And this finger wasn't there 3 months ago. So it has rapidly pushed into these tropical waters. Mm-hmm. And so people say that the oceans are boiling. Take a look at this map. This is yesterday's sea surface temperature. There is almost no hot ocean. There's a little bit here, which is the Gulf of Mexico, but most of the ocean is not hot.
Right.
Absolutely ridiculous. Yep. There are some small areas of warm water, like here off the coast of Asia, which is always sweltering hot and humid. Mm-hmm. So look at how hot these inland seas are.
Yeah, I know. But that makes sense, right? Like those places are going to trap heat, So it's like...
And so the reason the climate model is so sensitive is because these deep water upwelling events causing these cooling patterns. So what we have right now is 2 hurricanes in the Pacific, and they're moving towards Hawaii. One is moving to the south of the islands here in the warm water, and it's going to increase into a hurricane. The other one is tracking just north of the islands, and it's forecast to break up right here in the green water. And because that's not warm enough to have a hurricane, it just breaks down into a tropical depression. So this La Nina is really affecting, our entrance to La Nina is really affecting the hurricane season. They said that we're going to have dozens of named storms. We're barely at, I don't think we're even at D yet.
Yeah.
There are no hurricanes that appear to be forming at all in the near future.
Yeah, I mean, it's a little early, right, for hurricane season at the moment. More, at least for the Atlantic, right? Most of that we see in the fall. But
no, it ends in October. This is peak, August.
Oh, this is
September.
Peak. Okay.
Yeah.
Okay.
Yeah. So we're in peak, and there's nothing happening.
Right.
And there's certainly very little going to be happening in the Pacific this year at all, or anything threatening the Hawaiian Islands. They're in cool water.
Yeah.
So any hurricanes in the Pacific are going to affect Baja, if that, because this is the only warm water that they can sustain themselves. Mm-hmm. So what does it mean for us? It means we're rapidly going into La Nina. The prediction is, if I can open this, somehow it just doesn't want me to look at this figure. There it is. So this was just issued this month. This is the prediction. So the way these work is they have a composite of 3 months, July, August, September, and the average is going to be ENSO neutral. Even though I just showed you that graph, we've rapidly dropped into La Nina. So this is more like what it looks like right now.
Yeah.
August, September, October. So right now we are rapidly going into pure blue for September, October, November, and we will remain in extreme La Nina for the entire winter through spring. Ding, dang.
Yeah.
And that means more extreme snow events for the Northeast and the Pacific Northwest and the Rocky Mountains.
Yeah.
So the whole fraud of no more snow is going to be beaten over the head once again this winter when hundreds, if not 1,000 inches falls again in Utah. We'll get 600 inches here at Wolf Creek Pass and maybe 14 feet down here.
Yeah. So we're basically re-entering the conditions we were in, let's say 2018, 2019.
Which would be this Nina here.
Yeah.
And then a couple years after we had some more heavy snows, that was right here.
Yeah.
But look at where we are right now.
Yep.
We're way lower than any of the other Nina patterns.
Yeah.
None of these really. Go ahead.
I mean, this graph too, I think for our area really helps make sense of the winters of the last like 2 decades, you know, because people who have lived here longer than us I've readily heard people complaining that, you know, we're not getting the winters that we used to get, which makes sense when you look at this because, you know, 2010 going forward, up until about 2015, 2016, there would have been heavier winters, you know, and then it would have petered off a bit. And then, you know, we got one more heavy winter. So I was thinking,
So we had the lowest river level ever in Pagosa right at this time, 2007-ish, because there was no snow.
Yeah. Right.
None snow.
Yeah.
So this La Nina, El Nino really does affect our area in big ways.
Yeah. It becomes very obvious here.
Okay. So we're not baffled anymore.
Right. Right.
There you go. So the reason that the Atlantic is cooling at a mysteriously fast rate is no mystery. Look at this, straight down. This is a 1 degree drop in those critical Nino areas.
Yeah.
And that's 1 degree C. That's a lot.
Yeah, it is. Yeah. By the way, the ENSO cycle here, I think we'll get into this a bit later, but this interesting paper that we have that was published just 4 days ago about the effects of albedo and TSI on climate does get into the ENSO cycle a little bit. And basically what they find is that the ENSO cycle is like a direct result of shifts in TSI.
It's the sun.
Yeah, what do you know? It's the sun. That thing that's not a static ball of heat. That has its own variability that affects us.
So keeping in the broad-based general discussion that we're having today about natural climate variability and climate cycles, we just went over the shortest cycle that's the most obvious, the ENSO cycles. Mm-hmm. These cycles are so obvious that there are geologic papers on ENSO cycles that look at ENSO cycles that are millions of years old. So this has been going on for quite some time here on Earth.
Yes. Nothing to do with us, interestingly.
So proxy data, we're going to talk about that real quick. This is an older paper. No, this is from 2014, January 19th. I don't know why I thought this was older. The influence of proxy selection on global annual mean temperature reconstructions during the Common Era.
By the way, you said 2014 a second ago. It's 2024. It just came out.
Yeah, that's what I meant.
Yeah, that's all. Just clarifying for our listeners and viewers.
So this is the key to the paper, the influence of proxy selection. Let's take Michael Mann, for instance. He went through all the proxy data and he cherry-picked the one that would prove that it's our fault. He looked at proxy data where the warming began at the Industrial Revolution and went up. And it just so happened tree rings gave him that and some other things. And he created his hockey stick because he cherry-picked the proxy data. Yeah. This paper is exposing that there is a huge influence on which proxies you look at. Mm-hmm. And Michael Mann certainly didn't do that.
Well, and more pointedly, the proxies show that the one proxy that really gives a different result versus the others is the tree ring data. Right. Yep. And the reason for that is because the trees are responding to larger amounts of CO2 because that's what they eat. That's what they consume.
CO2.
All of the other proxies show something different, which shows that that's not a good proxy for long-term temperature variability.
Oh, wow. I had no idea CO2 was plant food.
By the way, I was thinking earlier today that hockey shtick is really the perfect way to refer to this, right? A shtick is a gimmick. It's a Yiddish root. It's perfect. It's not a hockey stick. It's a hockey shtick because it's nonsense gimmick.
So what we're looking at is all the proxy data available here from different proxies, non-marine sediment proxies, tree ring data, non-tree ring proxies. And some of these proxies are like 018, 016 ratios of certain elements, beryllium, oxygen, and on and on. There are many different data sets you can look at and infer temperature. Mm-hmm. Some are more specific, like the oxygen isotope ratio is very specific to the temperature in the Arctic regions, which is why using that on ice cores gives us a pretty darn good temperature reconstruction for long-term history.
Yeah.
These proxies are a little bit more specific because they only span back a few thousand years. So this data set is even higher resolution. And what it shows is that back in the Roman times, it was much warmer than today. And people don't like that. These proxy data also show a warming trend beginning around 1600, which is not anywhere near the Industrial Revolution, which shows that the warming began far before we made factories.
Right.
Hundreds of years.
Yeah.
But no one wants to look at the data.
Right.
So we're showing it to you.
Right. I mean, even the fact that they try to deny things like the Roman warm period as well is also just silly from the perspective of, historically, generally speaking, we see incidences of higher civilization during warm periods, and that's part of the Roman history. It's just silly.
Right. At the very end of the show, we'll sum it all up with a civilization graphic overlaid with temperature, where you can see the Minoan warm and the Minoan Empire peaking at the warmest time in the last 6,000 years, followed by their collapse because it got really cold really quickly. And then the rise of the Roman Empire when it warmed up again, and so on and so forth.
Yeah, like, why do you think all of the Roman men were wearing tunics and sandals all the time? That's literally what they wore.
Because it was never cold. Anything else you want to talk about on the proxy paper? Nope. I just wanted to show the general temperature trend of the last 2,000 years. Although
it would be good if you showed, I don't know if you have it handy, but the summary of this paper by Joe Nova, because I don't know where it is in this paper, but they've got all of the non-tree ring proxy data overlaid together, showing that all of it shows this cooling trend until, the last 400 years versus the tree ring proxy, which shows the hockey stick.
Well, this has non-tree ring proxies here.
Oh, that's what I was looking for.
Straight down.
Yeah.
Yeah, right there. And then the tree ring proxies on the left here with Michael Mann's hockey stick.
Yeah.
So there's the hockey stick. And that's why he picked this data set. He's like, oh, good. Humans did this. Look at this. That proves it. But if you looked at, if he was honest and he looked at all of the proxies and saw this, it's cockamamie.
Yeah.
So in order to get the hockey stick, you got to pick your proxy.
Yeah.
Just like you pick your nose.
Well, and then this just goes to show, this is something I complain about all the time, is that, you don't have to do a lot of digging to figure out that the climate change stuff is nonsense. Like, you don't have to look very hard. All you have to do is just look at the data further back, or look at data like this, which just goes to show that the people who do this, who cherry pick data, they're intentionally lying. It's not a mistake. It's not a mistake that somebody made decades ago that's been built upon. It's an intentional lie.
For a purpose.
Yeah.
For some, it's to keep their job or to keep their tenure. For others, it's to keep their elected position, for their constituents.
Right.
And so all the world is a stage.
Yeah.
No truer words have been spoken. So this paper coming out by Ned Nikolov. I follow him. That's interesting.
Mm-hmm.
On ResearchGate, here is the roles of Earth's albedo variations and top of the atmosphere energy imbalance in recent warmings. New insights from the satellite and surface observations. For those who have no idea what we're talking about, because that title is a mouthful, albedo is simply the fraction of light that the surface reflects. Obviously, white things tend to reflect or prevent more sunlight from hitting Earth. So the tops of clouds prevent a lot of sunlight from hitting, because if you're in a partly cloudy day and the sun is out, it's warm. And then if a cloud comes between you and the sun, it becomes markedly cooler.
Yeah.
That's albedo.
Yeah.
If all of the light is reflected back into space, the albedo would be 1 and we would all be dead.
Mm-hmm.
The temperature would plummet 50 C in 24 hours.
Mm-hmm.
But hopefully that doesn't happen anytime soon.
Right. But that's, I mean, also precisely why, an ice age has some momentum behind it, right? Because you have more snow and ice, which is reflecting more sunlight into space.
Yeah, if the whole planet is covered in white,
right,
it's going to be cold out.
Yeah.
So if 30% is reflected, which is a good average on any given day because of cloud cover, then the albedo is 0.3. So that's a whole albedo lesson. You don't need to know any more than that.
Mm-hmm.
And what the paper shows is a direct correlation here. This is shortwave radiation in watts per square meter. This is coming from the sun.
Mm-hmm.
And you can see the sun is variable. And these are years. This is just the last 24 years. You can see the fluctuations here.
Yeah.
And the top graph here is albedo.
Yeah.
Which has a direct opposite correlation to shortwave radiation. Now, correlation is not causation. But so what are your thoughts on these data sets initially?
Well, I mean, the important point that this paper comes to is that the decrease in albedo and the increase in shortwave radiation from the sun is precisely what has caused some significant warming over the last 20 years. And what this paper is showing is that the amount of temperature rise can be fully accounted for by those factors with no need for anthropogenic global warming in the picture. So if you do the math and you look at those factors, which previously have not been really evaluated by the IPCC or anyone else, that's all you need to explain the warming. There is no room for some magical fantasy anthropogenic global warming in there. So it's just not part of the equation.
If the IPCC looked into this, they would literally cancel themselves.
Totally. This is really bizarre. Listen to this. This is from this paper. This is from early in this paper. The author points out that I'm sorry, I don't know what the exact report is, but one of the IPCC reports features two graphs showing a positive trend in the Earth's reflected solar radiation and a negative trend in the outgoing thermal flux since 2000 that are supposedly based on Ceres data. However, these trends are the opposite of what Ceres has actually measured and contradict prior published results. So these graphs here, they actually flipped the data to show increasing albedo and decreasing shortwave radiation, which I guess gives them the room to have some other factor to account for warming in the last 20 years. So it's just such a blatant lie. It's absurd.
So by lying, they're able to affect policy.
Yeah.
That's amazing.
It's really astounding. I mean, there are so many things in this paper that they do such an excellent job of explaining all of the mistakes that are being made. I mean, they even have a really great explanation for, and I can't explain it. I'll have to find it and read it. But basically giving the lie to this idea of greenhouse gases trapping heat and why that doesn't make any sense, and that there's actually a different phenomena occurring that explains the result of that. I'll have to find that section and read it because I just can't really explain it very well.
And look at this. This is the global temperature anomaly. This is the 2016 El Nino. This is the 2020 El Nino, and this is our El Nino we just left.
Yep. I think that the graph just above that, if I recall correctly. No, never mind. It's a different graph. There's one graph that I think it's just showing variability in TSI or something like that. And it clearly lines up with the solar cycle. It's like, no, maybe it's not TSI. What is it? Oh, it is TSI. It's the Ceres TSI anomaly.
Right here.
Yeah.
These are the solar cycles. 1, 2, 3.
It's like, oh, wow. What do you know?
So a couple other things going on here. We see a rapid decline here in albedo and a rapid rise in temperature. And this corresponds exactly at the time we banned bunker fuel 2 years ago. These ship tracks contributed immensely to daily albedo. Look at this. This is the Atlantic. This is the entire Atlantic Ocean.
Yeah.
So they eliminate all of these clouds by removing bunker fuel, and that causes this final spike in loss of albedo.
Yeah. Yeah, that's interesting.
Yeah.
I think they even mentioned that because I remember sometimes when we reviewed that, it's like referred to as like global brightening and global dimming. And with the elimination of the ship tracks, we have global dimming, meaning we lose that albedo effect there.
Right. And guess what else we had for the last 2 years with all the green alarmists with their chickens with their head cut off screaming, the ocean rapidly rose in temperature 1 degree. Oh my God, this is unprecedented. It's literally their fault and their policy which caused the ocean to rise in temperature. I find that hilarious.
Yeah.
Because they're actually heating the earth through their policies.
Yes. Yes.
Oh, what a ruse. All right. Anything else you want to talk about on this paper?
I'd like to try to find, if I can find it quickly, what I was saying earlier about the explanation that basically supplants the greenhouse gas trapping of heat. That's nonsense. I don't remember. I don't, like I said, I can't really explain it very well, but it's essentially based on the air pressures that are sort of just based on the physical dynamics of Earth and what it does with shortwave and longwave radiation. Like there's a perfectly good explanation without having to resort to this greenhouse gas stuff that's trapping heat. So, I mean, it really goes to show in science how many elements of this study have been completely neglected, right? The fact that here we are in 2024 and no one has bothered to evaluate how much of a contributing factor albedo is, how much of a contributing factor TSI is, although it does seem like some people have done some of that work because I think we've seen some of that before. Nobody's been looking at this all this time in all of these decades. Like that's completely absurd. But that probably comes down to, what we've talked about many times is the lack of funding, right?
Yeah, the system will not fund that project.
Right. Like if you say, I want a grant to write a paper to determine how much albedo, how much effect that has on the temperature on Earth, nobody's going to give you the money to do it.
Nope.
So that's why it's not there. So I don't know what Ned Nikolov's what he did to get funding, or maybe he didn't need the funding for whatever reason. But this is a fantastic paper. It really is.
Well, and this was run by the Forest Service, so they had some government money there.
Yeah.
It's USDA Forest Service out of Fort Collins and a cooperative institute for research in the atmosphere. So some independent guys went out to look open-minded at this, and they came to some startling conclusions that there's no need for a fake story of man-made global warming through CO2, because when you look at the data, all the albedo and TSI data is all you need to account for all the warming. CO2 is not necessary.
Right. It gives me a little bit of hope that perhaps the tide is turning a little bit in terms of research coming out, like this, that really investigates the truth of how temperature is determined on Earth.
Yeah, exactly. All the links to all the papers we talk about will be below, so you can peruse them at your own time. Now, in the second half here, we're going to blow your mind. This is for the average person to share around with your global warmist, psychopath, greenies, or whatever, your climatards, however you want to refer to them. Because there are multiple papers coming out in the last decade showing, exposing the truth. The first one is that Greenland was nearly ice-free for extended periods of time during the Ice Age. We're still in the Ice Age, but apparently in the past, within the last few million years, there's evidence that showed up as early as, here's a paper from 2016, right? I got a paper here also. I think I erased it. I had one from 2007 as well. But the reason I didn't put it up is because it was more hypothetical. They were guessing at that point, but now they have the data from these boreholes.
Oh, I have that paper handy. Yeah.
Okay.
This is the one that was this the one where they're looking at DNA? Yeah, it is.
Yeah.
And they were using PCR to examine the DNA that they were finding. Yeah, so a little bit more theoretical, but
so the more recent papers they actually got material from the bottom of the borehole where the ice meets the surface of Greenland.
Mm-hmm.
And the data set shows that the southern tip of Greenland, which is now under 2 kilometers of ice, let that sink in, was ice-free during the Ice Age. And the media would have you believe that this is the hottest year ever.
Yeah.
So during the Ice Age, southern Greenland was ice-free. There's other reasons we know this. The Vikings lived there.
Mm-hmm.
Oh,
well, it also goes to show that you can't utilize one particular location on Earth to make determinations about what exactly was happening when, as far as temperature, right? Like you can't look at it from just one location. That's meaningless. You have to look at the entire globe and see what was going on. You know, because there's always all of this hullabaloo created about like, oh, you know, this particular glacier is melting and that means, you know, the world is ending. And it's like, no, it doesn't necessarily work that way. This part of Greenland was ice-free during the Ice Age.
Yeah. Which we're
So
still
what does that
in.
tell you?
Which we're still in, and it's not ice-free. Let that sink in.
Right.
Yeah. So in an area that was ice-free during the Ice Age, there is now 2 kilometers of ice on Greenland. It is not the hottest year anything. In fact, they found plant, insect, and fungi fossils under the center of Greenland's ice sheet.
Mm-hmm.
That's 3 kilometers thick.
Right. Right.
That's more. Do you know how long a mile is? That's how thick the ice is.
Right.
Holy macaroni. All right. Ancient biomolecules from deep ice cores reveal a forested southern Greenland. And
this
so
is the 2007 paper.
Excuse me?
This is the 2007 paper.
Okay, cool. And their conclusions when they do the dating analysis here place the southern tip of Greenland ice-free somewhere between, let's say, 400,000 years ago and 900,000 years ago. Maybe the whole time. So there could be a long period of time during the Ice Age where Greenland was ice-free. And we know in more recent times, i.e. the time of the Vikings, that the southern tip of Greenland was probably also ice-free.
Mm-hmm.
Because a large population of Vikings lived there, which is a great segue to your glacier thing. It's funny how the alarmists removed the ship tracks and heated the earth. Thank you.
Mm-hmm.
And then they blame melting glaciers. That's our fault. But when the glaciers actually melt and reveal things like forests that are just 2,000 years old underneath of them, it means that those areas didn't have glaciers during the Roman warm.
Right. But they do. But there's a glacier there now, and yet it's the hottest year on record. Always.
Yeah. So the Mendenhall Glacier started to unravel the global warming scam. Researchers found an entire forest underneath of parts of the Mendenhall Glacier that are melting. Where did they date them? Just 1,000 years old.
Yeah.
And that was another warm period called the medieval warm. We'll get to all of these times.
Yeah.
So 1,000 years ago, it was clearly much warmer than today. There were no glaciers in Mendenhall.
Right. Right.
So we're going back to maybe similar times because we're now in what's called the modern warm. It's just a repetition of a millennial cycle that's been happening for the entire Holocene.
Yeah.
So about every 1,000 years, it gets warm and all the glaciers melt and Greenland recedes, and then it gets cold again and they all build back.
Yeah.
Yep, that's the cycle.
I mean, the evidence here under Mendenhall also shows that there was a glacier advancing, right? Like you can see the evidence of that as well. So that's kind of interesting.
Yeah, a gravel layer about 4 to 5 feet thick appears to have encased the trees before the glacier ultimately advanced enough to plow over them, snapping off limbs and preserving the stumps in an ice tomb. So as the glacier is advancing, in the front of the glacier, you got things running off underneath the glacier. There's
You've got
underground.
meltwater that's
Yeah.
pushing gravel, all of that. Yeah.
And so it was able to cover the stumps before the tops got sheared off, preserving the stumps in this gravel.
Right. Right.
Absolutely fascinating. So this discovery shows that 1,000 years ago, it was warmer than today. And in recent years, other things have been opening up as some areas that are warm are melting glaciers. Here in Norway, they found a hidden Viking trade route. And all of the stuff along this road, including like kiosks and markers, were perfectly preserved because it was like one winter, it got bad, and then no one could go over there for hundreds of years. And these are trade routes that were used daily to ferry clothes, food, and other goods across the mountains. And guess how old these are?
I was about to say about 1,500 years or so.
Yeah, 1,700-year-old wool tunic was found, likely belonging to a Roman era hypothermia victim.
Interesting.
So that's interesting. And we've also got, go ahead.
It also gives the impression that these time periods where things open up a little bit and it's warm enough to like reside in these areas, that's kind of like a short window. And maybe that's part of why we've missed this in the past.
Yeah, but at these warm times, every 1,000 years, the whole world goes frenzied into global trade and everybody's moving around. And that's when all the monumental churches and structures are being built during the empire. Yeah. And then it all crumbles for a period. It's almost like the earth breathes every 1,000 years. Absolutely. Life and death. Yeah. So we've got all this trade going on during the Roman warm over high passes, melting glaciers in a Swiss region between the Serrug and the Transflugron Glacier. The same thing happened there. Exposed bare rock that had been frozen over since the Roman era. And so, interesting there. And here's where it all comes together, where all this is coming from. So that 1,700-year-old tunic is from this warm peak right here, which is the final gasp of the Roman Empire. A brief Roman revival and reunification occurred around 1,700, 1,600 years ago. And there it is. It's during a warm time. The Roman warm collapsed here. And this is the fall of Rome. Yeah. And then it warmed up and a reunification happened. And then it got horrendous. And the European Dark Age happened. And we've got bubonic plague, starvation, and very little information of what happens down in that hole.
Yeah, I mean, it really, the absurdity of, freaking out about warming, given that when the warming drops off, things get bad. I mean, these people have their perspective on this really backwards.
Well, that's communism, isn't it?
Yeah. So right. I mean, right. Like that's what we're in the middle of, right? Let's destroy everything.
Yeah. So all of these warm periods, life on Earth prospered, the Minoan warm, and then right after the spike, the temperature falls straight off a cliff every time. Yeah. There's no exception to this cycle. Yeah. And the empire collapses. Yeah. Here, straight on the way down, halfway down, the Mycenaean civilization collapsed. Palaces were plundered. The Hittite Empire fails. It was the end of the Bronze Age. There were droughts in the US, India, Europe, Africa, China, and West Asia. Starvation and a dark age. This was even the collapse of the Egyptian kingdom. Yeah. Right at the bottom. This is the end of Egypt. And there are no more Egyptians there. Yeah. And so there's very rough period here. Look, for 1,000 years, it's kind of crappy and it warms up and then the Romans take over. Yeah. What were you saying?
I was just thinking, last week I was explaining to somebody that I think that, people like Bill Gates who come up with these plans, let's say to like inject salt into the stratosphere to cool the earth, stuff like that. Like I don't think that Bill Gates doesn't know about this stuff. I don't think he's ignorant of the real data and the correlations with high civilization. I suspect that he would like to be able to take credit for cooling on Earth, which is inevitably going to happen based on this graph, right? And soon. And so, if he does something insane, like inject salt into the stratosphere and then it cools, he can say, "Look, I fixed it." But you know what that also means? It also means that he really becomes the devil because stuff is going to get terrible once that happens, clearly, based on this graph.
So those evil people are well aware of that if they are able to end the warming by injecting salt in the sky, they realize that the entire population will die off and suffer, which is exactly what they want.
Right. Because if you have way fewer than 8 billion people on the planet, it's going to be a lot easier to control them.
And take a look at the modern warm. We've spiked. It's relatively the same peak as every other peak. And after we peak, what happens? It drops straight off a cliff. So we're about to see at least a 2°C temperature change in the near future.
Yeah.
And it's going to be to the down, to the cold.
Yeah.
So that's the pattern.
It's just a question of how far down will it go, really.
And right. And is this just another one of the millennial scale grand minimas? Or is this actually the end of the Holocene warming, which is the interglacial, in which case the temperature drops 15°C?
Yeah.
That's the big one.
Yeah. And that's an important question, too, because when you look at this graph, where we are temperature wise right now in the modern warm is really not that different than the temperature range after the Minoan warm.
It's pretty much the same temperature at max here. It's the cool periods that kill and empires, though.
Right. So that would suggest that we likely would reach at least a little ice age range of temperatures.
Right, because if you look at the trend of the grand minima bottoms and we connect the dots, it goes this way, straight down.
Yeah.
There's the trend. It's been cooling for 4,000 years.
Yeah.
We just happen to be in a hot spike.
Yeah.
So the next down could be lower than the Little Ice Age or the European Dark Age, somewhere down here.
Yeah. Yeah.
Which is bad news. The good news is that it's going to take, it takes a few decades to do the drop.
Yeah.
So we'll probably be close to death if it's cold.
Yeah. Yeah.
We'll be 80 sitting next to the fireplace.
Yeah.
But if a magnetic excursion accelerates this, this graph means nothing. These little fluctuations pale in comparison to a magnetic excursion.
Yeah.
So it's just amazing. This is so let's just look at this little part here, the last 500 years to get a better picture. This must have been terrible. I mean, this has got to be the worst time to be a human anywhere.
Well, this is bubonic plague era, the beginning of this. This is the medieval dark ages, right? This is not a good time.
Yeah, they pinpoint the Great Famine and Black Death is right there.
Yeah. This is not a good time to be alive.
What was it? 560, 530. What's the worst year to be alive?
It's 5 something.
Yeah, it's right here.
I can't remember.
It's probably this dip.
No, actually, because 1000 AD is at the top of the medieval warm.
Yeah. Oh yeah, so 586 is here, the European Dark Age.
Yeah. Yep. Is it 536? I think it's 536. Yeah.
On here, starvation, extreme cold, over a third of Europe population dies in 784. That sounds like a bad year to be alive.
Yeah. Yeah.
And here is this is the 530 whatever right there. But there's no arrow or explanation. So Rabaul and Papua New Guinea erupts and the sun lacked brightness. I wonder if that resulted in this cold.
Mm-hmm.
Because a lot of these papers also, I forget which one, conclude that one of the most substantial things affecting Earth's temperature is albedo and TSI, but the albedo can be affected by volcanoes.
And that's discussed in that paper too.
Yeah.
Yeah.
So you don't need man at all to explain any of this.
No.
What a
Like
tragedy.
literally what that paper says is that 100% of the warming can be basically explained by the decreasing albedo. It's like and then you see the variability when there's volcanic activity, because that's going to be blocking out the sun and is going to reduce the amount of shortwave radiation making it to the surface.
It's amazing. It's almost as if we have enough information to completely debunk the man-made global warming hypothesis and end the fraud of climate science once and for all, yet nobody's willing to do it.
Yes.
The most recent Hadcrut data set, even with the tinkering they've done, is still a full degree C lower than the proposed Mycenaean warm high temperature.
Mm-hmm.
Which means that just a few thousand years ago, it was several degrees Fahrenheit warmer on Earth, and therefore it is not the hottest year ever.
Yes.
Absolutely. Go ahead.
It's funny too, because the paper we were just talking about, the albedo paper, also talks about how the in general the mainstream science says things like, we don't know how to explain, the warming of the last 20 years. There's a big knowledge gap. And they're like, yeah, like this is the knowledge gap. It's all of this stuff that you haven't looked at in terms of its contribution to temperature change on Earth. It's hilarious.
Well, we've got a long way to go. The good news is that there is a way to survive all of these fluctuations because we have, and we're doing this show right now.
Yes.
But what happens during these drop downs is the end of the empire, famine, and death. So in order to hedge your bets on that, the same thing we've been saying for the last 10 years, move to a rural area away from cities, because if there's some type of plague or disease, you don't want to be near groups of people.
No.
And if you're alone on your own, you can grow your own food and harvest wild game. You have the best chance of survival, because that's how we survived in the past.
Yes. And another reason for not being in a high population density area is you don't want to be in a high population area if you're growing food or you have food stores or both. You don't want to be near lots of people, because they're not going to have food and they're going to go looking for it. So they're going to come to you. So that's a really good reason to be in a low population density area.
Yeah. And
because all of these changes in temperature are going to affect commercial agriculture in a huge way. Plus all of the political contributions. We were just talking to your friend Andy, who lives in New Jersey, and I had the same conversation with my father when he was here over a month ago, talking about how they can't get any good produce in their stores anymore, that it's all crap. And I don't know what the exact reason for that is, right? Like, I don't see any reason why you couldn't grow good, like we talked about, New Jersey grows corn and tomatoes and peaches and stuff like that. But for some reason, all of that stuff is like not available to them right now. Now, regardless of the cause at this particular moment, there will be a point where climate change, natural climate change, not human-induced climate change, but natural climate change will affect the ability to grow certain crops where they've always been grown. So, that's a good demonstration of having some kind of deficit. Like, I would be really unhappy if we could not get the kind of produce that we are able to get out here in Colorado currently. If we would just end up growing what we need, and that's what we're doing. We're gradually growing more and more of the produce that we want. But like that should be a signal that you need to account for your own needs. Like, this system is not going to last through climate change, and certainly not through all of the political upheaval that we're seeing now.
Natural climate change.
Yes. Yes. I have to keep clarifying that.
You need to clarify.
Yes.
All right, folks. So there you have it. That was a great show. If you have any questions, leave them below. We would be happy to answer them. And you're only going to watch this. This is not going to be a replay tonight on Magnetic Reversal News. So if you haven't subscribed yet, subscribe to the channel. Hit the thumbs up. It helps with the algorithm. Anything you want to say, babe?
No, great show.
All right. Be safe. We love you. I got to turn this off. Holy macaroni. Say something. It's dead air. I can't get in here.
You're still recording.
I know. I'm stuck.
Oh, you're stuck. I can stop it.
All right. Bye-bye.